Hello everyone and welcome to our channel PhysioSaurus. In today's video, I'm going to talk about the extrinsic extensors muscle. Okay. So in the previous video, we were talking about the extrinsic flexor muscle. Okay. So this is just a continuation video to that. Okay. Now let's start the video. So in extrinsic extensors, there are three muscles. Okay. So in this video, we are going to learn about these three muscles in detail and of course point wise. Okay. So that will be easy to remember. So the first muscle is extensor digitorum communis. Alright. So in short, we will write it as EDC. Okay. The second muscle is your extensor indicis proprius, which is your EIP. And the third one is the extensor digiti minimi. Okay. So in the short form, we will write it as EDM. Okay. Now, so these three muscles, they passes from the forehand to hand beneath the extensor mechanism. Okay. It's not forehead, it's forehand. Okay. Forehand. Now, at MCP, the EDC muscle of each finger, they merges with the broad aponeurosis, which is known as your extensor expansion or dorsal hood or extensor hood. Now about this extensor expansion or dorsal hood or extensor hood, I have already discussed it in my previous videos. Okay, so it would be better if you will just watch this series in the hand complex from the first video only. Okay, so that will make this a lot easier for you to revise everything and to learn everything. Okay, now the next point. So basically this point just says that at MCP joint, which is your metacarpophalangeal joint, the extensor digitorum communis muscle of each finger, that means except the thumb. Okay, so we are talking about particularly four fingers only. Okay, so EDC muscle of each finger except the thumb, they merges with the broad aponeurosis, which is known as your extensor hood. Okay, now the rest two muscle, which is your EI and EDM muscle, these two muscles has separate attachments with the index and the little finger. Okay, so only EDC muscle at MCP joint, it merges with broad aponeurosis, but the rest of the two muscles, they provide separate attachment with index and the little finger. Okay, now EDM muscle, they add independence to the movement of index and the ring finger. Okay, so when you will perform the movement of the index and the ring finger, so there is independent movement of these two fingers. All right, now let's talk about these things even in a little detail way. Okay, so the first thing is your index finger. Let's talk about the index fingers. Okay, so in index finger, the EDC tendon, it leads to extensor hood. That's the first point. Okay, and the second point is that EIP muscle, it inserts into the extensor hood on the ulna side of the EDC tendon. Okay, so basically let's assume that it's a hand. Okay, so this is your thumb. Okay, so in the thumb side there is your radius bone. Okay, and in the little finger side there is your ulna bone. So this one is your ulna. Now every finger has a ulnar side and the radial side. So this will be the ulnar side, this will be the radial side. For this finger, this will be your ulna side and this will be your radial side. Same goes with all the three fingers. Okay, here. Now what's happening here is in the index finger, the EDC tendon, it leads into the extensor hood. So it basically progresses and it inserts into the extensor hood. All right, but the EIP muscle, it inserts into the extensor hood on the ulna side of the EDC tendon. Okay, so it's only insert on the ulna side. Now let's talk about the little finger also. Okay, so EDM merges with the extensor hood with no EDC to little finger. So in little finger there is no EDC muscle. Okay, so that means that in little finger there is no extensor digitorum communis. Okay, however in 30% of the cases EDC is present. Okay, so this was about the little finger. Now let's talk about the middle and the ring fingers also. So middle and the ring finger, they don't have their separate extensor muscle. They only have extensor digitorum communis, which again leads into the extensor hood. Okay, now this extensor digitorum communis of one finger might be connected to the tendon of the adjacent finger by the junctura tendini. So you could just look at this diagram here. Okay, so as you can see here, this one is your junctura tendini. Okay, so it is present between the two fingers. Okay, so this is what it is. So EDC of one finger might be connected to the tendon of the adjacent finger. So that means two fingers are connected through junctura tendini, which is a part of the extensor digitorum communis tendon. Alright. Now, what will it do? So it will lead to extensor of the adjacent finger when one finger is extended actively. Okay. So active extension of any finger will lead to extension of the adjacent fingers. Alright. So when you will just perform the extension of the middle finger, you will see there is extension of the ring fingers also. Alright. Now let's move on. So this one here is your extensor retinaculum, which you can see here in this diagram. Okay. And again, this one is the diagram of the extensor digiti minimi, extensor indicis pollicis. Okay. This was already discussed, and this one is your extensor expansion or the extensor hood. Okay, at the MCP level. Now let's talk about the function of these muscles. Okay, so EDC, EIP, EDM, junctura tendini, all these connection results into most independent extension of the index finger with extension of the little, middle and ring finger in declining order of independence. So basically there is most independent extension of the index finger and then it decreases. Okay, so it goes on with this order, like the first will be your index finger and then it decreases with middle and then ring. Okay, so it somewhat decreases like this. All right. Now the EDM, EDC or EIP, these three muscle extends the MCP joint of fingers via connection to extensor hood. All right. And sagittal band. Okay, once again, this sagittal band has been already discussed. Okay, volar plate has been already discussed. Okay, so these three things are already discussed, so I'm not going to discuss it again. Okay, so EDM, EDC and EIP muscle extends the MCP of the finger via connection to the extensor hood, which you can already see in this diagram. Okay, that interconnect the volar plate and EDC tendon extensor hood. All right. Now, active tension on the extensor hood from one or more muscle will extend the MCP. So basically, when the tension is created in the extensor hood, okay, because of one or more muscle, that will lead to extension of the MCP joint. All right. Now the last function is the extrinsic extensors also act as wrist extensors. Okay. Now the last point. In this point, I'm going to discuss about the extensor digitorum communis. Okay. So it is basically a complex, it has a very complex kind of structure and very complex kind of function too. Okay. So distal to extensor hood, that means when you will go distally from the extensor hood, on that point there is joining of the EIP and EDM with EDC muscle. Okay, and EDC muscle at each fingers, it splits into three bands. Okay, So one is central band which goes centrally, and then there is two lateral band. Okay, so you can just see that in this picture. All right, so this one here is your extensor expansion or the extensor hood. This one is your EDC tendon. Okay, so the EDC tendon at MCP level that divides into three band, two lateral one and the middle one is your central band. All right, and these two lateral band, they joins again, okay, and it forms the terminal tendon. All right, so I'll just repeat whole of the sentence again. So distal to extensor hood, where is joining of the EIP and EDM muscle with EDC muscle. Okay, so from there EDC muscle at each finger splits into three band. The first one is your central band, and then there is two lateral band. Okay, and then these bands connect again to form the terminal tendon. So basically two lateral band connects again to form the terminal tendon. Now this central tendon, it inserts on the base of the middle phalanx. Okay, and the lateral band, which is 2 in number, and it connects to form the terminal tendon, it inserts in the base of the distal phalanx. All right, now the last point. Okay, so see the tension on the extensor hood, it can produce MCP joint extension. Okay, now since EDC muscle has two parts, the central tendon and the terminal tendon. Okay, so the terminal tendon is of course made up of two lateral bands. Okay, so when there is tension on the extensor hood, that can produce MCP joint extension, but central tendon and terminal tendon, which is located distal to the extensor expansion, it cannot be tightened sufficiently by the extrinsic extensor muscle. Okay, so if it cannot be tightened sufficiently, of course the full range of motion of PIP or DIP joint extension won't be achieved. Okay, so in order to produce full extension of the PIP or DIP, EDC muscle, okay, requires the help of the two intrinsic muscles. Okay, and that has attachments to the extensor hood and lateral bands. Okay, so this is just a simple note to understand the mechanism of all these muscles. Okay, now let's understand this concept in a more simpler way. Okay, so the first line was, if there is tension in the extensor hood. Okay, so if there is tension in the extensor hood, that will cause the extension of the MCP joint. Okay, and this tension in the extensor hood will be due to extrinsic extensor, particularly EDC muscle, extensor digitorum communis muscle. Okay, now after MCP or at the level of MCP, it was divided into central tendon and two lateral band, which again merges to form the terminal tendon. Okay, so this two parts of the EDC muscle is not tightened sufficiently by the extrinsic extensor to produce the PIP or DIP joint extension. Okay, so basically when you will perform the extension of the finger, not only there is extension of the MCP joint, but there is also the extension of the PIP and DIP joints. All right, so this is what I'm saying, that when there is tension in the extensor hood, that will cause the extension of the MCP joint, which will be due to the extrinsic extensors. Okay, which is your EDC muscle. Okay, and it has two parts, central and the terminal part, which is tightened insufficiently by the extrinsic extensors. Okay, so there will be incomplete range of motion of PIP or DIP joint extension. All right, now to achieve the full extension of the PIP or DIP joint, this same EDC muscle will take help from the intrinsic muscles, all right, and both of these muscles, they come into action, and that will lead to full range of motion of the extension of the IP joint, PIP and DIP both. Okay, so this is it, this was the concept. Okay, so the video ended here. Thank you so much for watching this video. If you have any kind of doubts related to this video or any kind of thing in your academics, feel free to ask me in my WhatsApp or in the comment section. Okay,